Hey guys, today we're going to talk about rate of change. So rate of change is miles per hour, feet per second, um, the money per year, something like that, something per something. We know it as slope. But of course, since this is calculus, we're not just going to say, hey, it's slope, and then move on with our lives. It's more complicated than that. So just as a reminder, to find the slope, we're going to take the difference of the y values and divide that by the difference in the x values. Or sometimes you might see it as delta y over delta x. Delta in math means change in. So we'll take the change in y divided by the change in x. So just as a quick little example, looking for a rate of change from a line, so looking for the slope of this line. So if we wanted to look and use the formula, maybe we'll use the point here where we're going through the point 1, 1, or sorry, 0, 0, and then right here we have the point 1, 30. So then maybe we'll use our slope formula. We'll take our y values and subtract them, 30 minus 0, over our x values subtracted, 1 minus 0. So we end up with 30 divided by 1, which is just going to give me 30. But remember, my y's were miles, my x's were hours. So we're going to have miles per hour if you want to put mph. If you want to put 30 miles / hours, that's totally fine. But if you notice right here, that hour is on the bottom, and he has an exponent of 1, right? So sometimes, not often, but sometimes, this will be written as miles, and then the hours are there with a little -1. Because remember, if they're sad, they need to move to where they're not. So just letting you know, that's going to happen more when we look at acceleration and things like that, but just wanted you to see it once. Now, if we picked other points on this graph, like maybe here, when we are at 390, we could still subtract our y's, subtract our x's, and divide and still get that same rate of change. Because that's a line, right? Slope, you're going to have the same slope between each and every point. So what happens when we don't have a line? How do we find the rate of change? So when we want to find a rate of change on something that's not a line, they usually give us an interval. So first, we want to find the rate of change on the interval from 0 to 1. So really what we're looking at here is we're trying to find the slope of the line that passes through the points x equals 0 and x equals 1. Or in this case, t equals 0 and t equals 1. So we'll take our y values and subtract it. So we'll have 96 minus, and then my other y value, let's see, is 80, over, and then we have 1 minus 0. And then we'll simplify. So we'll get 16 over 1, or just 16. And it doesn't tell me what the time is, so let's pretend this is seconds, and let's pretend this is feet. So that will be 16 feet per second. Now we want to find the rate of change on the interval from 1 to 3.5. So basically that is, I want the slope of the line from 1 to 3.5. So to find the slope there, we're going to take our y values and subtract them. 96 minus 0 over, and then we'll subtract our x values. 1 minus 3.5. So we'll take 96 minus 0 and get 96. And then we'll take 1 minus 3.5 and get negative 2.5. Then we'll go ahead and take 96 and divide him by negative 2.5. We will end up with negative 38.4. And that will also be in feet per second. So in this case, when we don't have a line as what we're trying to find the rate of change, the rate of change can be super different, right? So between between 0 and 1 second, we're going upward at 16 feet per second, and then we're going downwards at 38.4 feet per second on a different part of our graph. So what do we want to do when we want to be able to find a rate of change at one specific spot? So there's a link right here to a Desmos graph. You can also get there by going to the Desmos graphing calculator, clicking on the three little lines up in the top left corner and go down to where it says calculus secant line. That's what we're looking at here. See, calculus secant line. So we're looking at a weird sine guy going on here, but let's look at what we want to do if we want to see something at just one rate of change at a single point. So we can see how that would change here. Maybe we can move this point, see if we can get it closer to the other guy. So we're going to see how close we can get it. Ooh, so that way we can try to find our slope right here. So we'd want to be able to get those 2 points as close together as we possibly can, right? Trying to find the slope between two super close x values. Trying to find the slope between those 2 points. So what we want to do is what we can actually use this formula right here. We'll take f of whatever our variable is, f of x, and we'll put a plus h in there. Then we'll subtract out our function, and then we'll divide that by h. That is called the difference quotient. So all of these things are all of these things up here. So this is the slope of a tangent line, instantaneous rate of change, the gradient of the tangent line. This is the definition of derivative, and it's called the difference quotient. So we'll have other ways to find the derivative here in the next lesson or two, but right now, if we're talking about the definition of derivative, if they say to find the derivative by the definition of derivative, it's going to be this guy right here, the difference quotient. So let's work this guy out to find the gradient of this tangent line, which remember is the same thing as the difference quotient or the slope of the tangent line. Gradient means slope. Gradient means slope. Good deal. So if we want to find the gradient of the tangent line here, we want to use our difference quotient. So first of all, let's talk about f of x plus h. Let's find him first. So what we'll do is we'll just go ahead and plug in x plus h in for x. So we'll have 2 times x plus h plus 3. And then if we simplify that, we're going to end up with 2x plus 2h plus 3. Good deal. And then we also know that f of x, I'm just going to write it out again, is 2x plus 3. So now we're going to go ahead and use that formula. So we should have the limit as h approaches 0 of, and then f of x plus h goes in first. So that was my 2x plus 2h plus 3. And then we need to subtract f of x, so minus, and then I would really encourage you to put parentheses around f of x, 2x plus 3. And then all of that is going to go over h. So I put in f of x plus h right here, and for f of x plus h, minus my f of x all over h. So now we want to distribute that negative on through to everything in the second set of parentheses. So now we're looking at the limit as h approaches 0 of 2x plus 2h plus 3. Then we distribute that negative through, so I have minus 2x minus 3 all over h. So now what we'll do is we'll simplify. So I have a positive 2x and a minus 2x, so those will add to 0 and cancel out. I have a positive 3 and a negative 3, so those will add to 0 and cancel out. So now we're looking at the limit as h approaches 0 of 2 over h. Well, then the h's should go ahead and cancel out. By the way, up here, everything without an h should cancel out. If you're left with anything with an h in there after you start canceling things out, you've done something wrong. Everything should have an h at the end of it. Cool, so here those h's will divide away. So we're looking at the limit as h approaches 0 of 2. Well, if we're just thinking of 2, that's just a horizontal line. So what's my limit at 0? Well, it's going to be 2. So the slope of our tangent line there is going to be 2. Now, you probably would have been like, duh, Mrs. Davis, I know the slope of the tangent line is going to be 2 because this is a line, and hey, my slope is 2. So that kind of makes sense. Cool. Let's look at it in a more complicated one. All right, so let's find the difference quotient of this one. So what I like to do first is, of course, we're going to need that f of x plus h. So I'm going to try to find him. So everywhere I see an x in f of x, I'm going to put an x plus h. So I have x plus h squared plus x plus h, and 4x there. And then we'll have a plus 3 at the end. Now remember, when we square something, we multiply it by itself. So you're going to multiply x plus h times x plus h. When you multiply that out, you're going to end up with x squared plus 2xh plus h squared. And then we still have that x plus h, and then plus 3 there at the end. So there's what f of x plus h is equal to. So now we'll put that into our formula. We're going to have the limit as h approaches 0 of, oopsies, of, and then I'm going to need my f of x plus h. So that was x squared, sorry about that, plus 2xh plus h squared plus x plus h plus 3 minus my f of x, right? I'm supposed to subtract all of my f of x. F of x is just this thing right here, x squared plus x plus 3. So this big chunk at the beginning is f of x plus h. That guy after the subtraction sign is f of x. And all of that goes over h. So now we need to make sure that we distribute the negative out to everything in the second set of parentheses. So right now we have the limit as h approaches 0 of x squared plus 2xh plus h squared plus x plus h plus 3. Then when we distribute that negative, minus x squared minus x minus 3. And then all of that goes over h. Now, right now, it's this huge, big, long problem that's disgusting, but it's not going to be disgusting for long. So what we'll do now is go through and cancel out everything that we can. X squared, negative x squared, add to 0. Positive x and negative x, add to 0. Positive 3 and negative 3, add to 0. So we should be left with stuff just with h's left over. Oops, that's hard to read. So we have 2xh up on top plus h squared plus h. And all of that is over h. So remember, I told you at this point, everything on top should have an h in it. And it does. So we're good. Now, if we plug in 0 right here for h, we'd be dividing by 0, which is a no-no, right? We'd be undefined. So now what we want to do is go ahead and see, can we cancel out or divide away that h? So that way when I do plug in something, 0 for h, it'll come out pretty. So let's take a look. My advice from this point, limit as h approaches 0. Each of those things in my numerator has an h, right? I would encourage you to factor out that h first, because if you don't, it's really easy to cancel things out and then not remember that it divides away to 1, and you're missing a term and blah, 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 blah. So I encourage you to divide it away. So 2xh, I'm sorry, factor out that h. We just have a 2x. H squared divided by h is h. And then h divided by h is 1. So we actually have a plus 1 on the end of that. Now I have h divided by h, and now I can cancel him out. So now I'm looking at the limit as h approaches 0 of 2x plus h plus 1. Well, now I can plug in 0 for h because it won't make my fraction undefined. So if we plug in 0, 2x plus plugging in 0 for h plus 1 will lead me to be 2x plus 1. So that is my difference quotient. That's the equation of the slope of the tangent line. Now, the reason it's not just a plain old number is because for us to be able to find the tangent line at a the slope of the tangent line at a specific point, we would go ahead and plug that x value into that to get the gradient at that specific point. So this is just a general equation to say, hey, the slope of the tangent line will be equal to this. Just plug in your x value because the slope of the tangent line is going to change along the way. So I would love for you to go ahead, using the difference quotient, find the derivative of y equals 3x squared plus 2. Cool, so on that guy, what we'll do, we'll have to find f of x plus h. So we had 3 times x plus h squared plus 2. So remember, that means I'm taking 3 times all of x squared plus 2xh plus h squared. We still have that plus 2 on the end, nothing to do to him. And then I'm going to distribute that 3 on out. So we'll have 3x squared plus 6xh plus 3h squared. And then we still have that plus 2 on the end. So that's what we will put in for f of x plus h. F of x is just going to be our equation up there, 3x squared plus 2. So now we'll put that into our formula. The limit as h approaches 0 of, remember we're going to do f of x plus h first. So that'll be 3x squared plus 6xh plus 3h squared plus 2 minus our f of x, sorry for the squishiness there, minus, and then I like to put parentheses around my f of x so I remember to distribute the negative out, 3x squared plus 2 in there, and then he goes all over h. So now we'll distribute that negative 1 out to everything in the second set of parentheses. So we've got the limit as h approaches 0 of 3x squared plus 6xh plus 3h squared plus 2. Let's try that one more time. Okay, so now that we have distributed through that negative to our 3x squared and our 2, we're ready to rock and roll. So now we'll cancel out what we can. We have positive 3x squared and negative 3x squared adds to 0, and positive 2 and negative 2 add to 0. So just like we're supposed to, we're only going to have h's left on top. So the limit as h approaches 0 of 6xh plus 3h squared all over h. I think it is really helpful to go ahead and factor out that h in our numerator. So we'll have the limit as h approaches 0 of h times 6x plus 3h. Since we divide one of those out, he's still in there. Over h. So then our h's will divide away. And now we're left with the limit as h approaches 0 of 6x plus 3h. So now we can plug in 0 for h, since we won't be dividing by 0 and having it be undefined anymore. So this leads to me going through with 6x plus 3 times 0 in for that h, which will just give me 6x. So 6x is the derivative of 3x squared plus 2. All right. See you guys later.